So, welcome to Rational Expressions and Equations. Today we're going to be looking at our topic, prerequisite topic. Oops, better put my pencil on. And I'm going to just talk a little bit how you can use this note package to kind of keep yourself organized while you do this unit. So, the first couple pages, we have pulling it together. You can fill this in as we go through the unit, and it's going to go pretty quick. Remember, each class is like 2 classes in the regular year. So we're going to finish this unit. We're going to do most of the work this week, and then next week we will actually have our test on it. So it's probably a good idea is that every day you kind of go back to these pages on page 2 and 3 and just kind of jot notes in terms of what we learned and some examples. And this is something that you should probably use. It's your self-assessment, kind of taking a look at what you remember from previous courses, what you need to learn. Taking some time to go through the learner outcomes before and then after. And some of this you may not know how to do yet because you haven't done it before, or hey, last year was weird. If you had math second semester, it may be hard to really kind of know exactly what you do recall from your 20 level math. So for example, I can simplify rational expressions. Some of you may say, oh, I totally remember how to do that. Yes, or I kind of do. So checking your sums, or no, I'm going to need to know how to do that. And then you can check, no, not yet. So we're at the before stage. So it's a good idea to kind of go through and say, what do I know? And don't worry if all of these are no, not yets. The idea is that by the end, when you're prepping for your exam, you can go and that you're clicking off the yeses. That's the hope. So today we're just doing the pre-learning. Tomorrow we'll be doing topic 1. So you can take a look at this before topic 1 and kind of check and see where you're at. The next section, page 5, is some of the terms. As we learn each thing, you can go back and say, do I now know what those are? And can I give an example? And you can take some time to fill that in. And I'll remind you every day to go back to this page to kind of fill that in. What we're doing today is we're talking about prerequisite skills, exponents and factoring. This should feel familiar. And like I said, you may not remember all of it, but you should have some awareness of it from previous courses. Even grade 10, we talk a little bit about some of this stuff. So this is math you should be aware of. This is to review polynomial information for Math 10C. And again, those of you, we also revisited in math in your 20 level maths. And I know some of you have come from 20-1, so you do an entire unit on this stuff if you're from 20-1. From 20-2, you do work with some of this, but not all of it. So a power consists of a base and an exponent. Powers can be multiplied by a constant called a coefficient. And the exponent laws are laws that help simplify or evaluate powers. So power might be something like 3 to the 2, and this is our base, and this is our exponent, and the whole thing is the power. Okay. We also can have a coefficient in there. So if we have something, well, let's go through the individual things down below. So if I have this power here, 3x squared, in this power, the coefficient is the 3. The variable is x. X, a variable, is always going to be a letter, which means that it can change, can be substituted for with other numbers or with numbers. So it is variable because it changes. The power part of it is x squared. The base would be our x, and our exponent would be that 2 up top. Okay? So looking at the parts of it, that should be familiar. Okay? Now we're going to talk about how do we use the exponent laws. So we have a number of exponent laws, and first one is given to you is power of a product. And the rule with power of a product is that if we have 3 exponents with the same base, we can add those exponents. So this becomes a 2 plus 2 plus 3, or a to the 7th. Okay? If we have power, then the second one, we have power of a quotient. We, instead of adding those exponents, because now we're dividing, we're going to subtract. We subtract the bottom from the top. And we also can divide those coefficients. So -8 divided by 4 is -2. And remember, on the bottom, even though I don't write it, that c is to the power of 1. So this is 6 minus 1. So it would be c to the 5. So that's our, so this one here was using our power of a product. And here we have power of a quotient. We have another power of a quotient here with x over x to the 4th. Now, what we would do here, we could write this as x to the -3, because this would be 1 minus 4. But we don't like to have negative exponents, so instead what we would do is we would keep that. Remember that when you have a power to a negative exponent, you can move to the denominator and become positive, the exponent, so that would be 1 over x to the 3. Okay, so this is dealing with negative exponents. And there's another way we can look at it. We can look at it with, if I have on the top, I have an x over x times x times x times x. If I'm reducing these out, one of these x's will divide out with 1 on the bottom. So then that would leave me with 1 over x to the 3. That's basically what's happening there. But if you remember, if you have a negative exponent, you can just move it to the bottom, to the opposite. Because sometimes you get a negative exponent in the denominator, and if you want to make it positive, you move it to the numerator. So looking at this one here, we have 27 divided by 3, which is going to give a 9. And I have a to the 2 over a to the 3, so that's like a to the -1. And again, I don't want to have a negative exponent. That would not be in simplest terms. So this negative exponent here can move to the denominator, and I would get 9 over a. And you can write that 1 for your exponent, but I always like to say that mathematicians are lazy. So if we don't have to, we don't have to. If there's nothing there, we assume it's a 1. Okay? So hopefully that looked familiar. You're going to get some practice. Okay? Let's talk a little bit more about polynomials. Moving on to page 7. So looking here, when powers are added or subtracted together, a polynomial expression is created. Polynomial expression contains real number coefficients. So coefficients are those real numbers in front of our variables. It contains whole number exponents, and it can be written in expanded form or factored form. I am going to scribble this out, and I'm going to fix that. So recall the following sets. Real numbers are all numbers, real numbers including decimals, fractions, positives, and negatives, and whole numbers start at 0, go up, whole, 1, 2, 3, etc. Okay? So our exponents are going to be whole numbers in our polynomials, and our coefficients are going to be real numbers. So that means that they can be decimals, they can be fractions, they can be positive or negative. So we're going to take a look at that. So what does that mean? So that means that you could have y is equal to 3x, 3 plus 7x plus 6. So this is a polynomial function. Sorry about my writing. But y is equal to 3x3 plus 7 root x, because that square root of x would have that would be x to the 1/2 plus 6. This would not be. Okay, because this is the same as x to the power of 1/2. Okay, that's a little, so we're dealing with whole number exponents. Okay, we can write them factored or unfactored, but that's, sorry. Okay, simplifying polynomials. So let's do some practice in simplifying. Hopefully this seems familiar to you. So simplifying a lot of it, this is where we talk about collecting like terms. So I have a number of different variables in this first one. I have 2x squared minus 4x cubed minus 7x squared plus 2x minus 3 plus 5x plus 8 cubed plus 8 squared. So I'm going to collect my like terms. So let's look. This is an x squared, this is an x squared, and this is an x squared. I can combine all of those. So I have 2 minus 7 plus 1. So that would add up to negative 4x squared. Now let's look. I have negative 4x cubed, and I have plus 8x cubed. So I have, in total, I have 4x cubed. Now, why did I put that in front? I put that in front because we tend to write our terms in order, in descending order of what that exponent is. Okay, so that means that I want to make sure that I have my cubes first, then my squared, then just my x's, and then my constants. Okay, so now let's look for my x's. So I have plus 2x plus 5x, so that's plus 7x. And then last but not least, I have my minus 3. I'm going to write that out again, all in black, so we can make sure we can see it, because I know on some of these it's hard to see the green and the yellow. Okay, so this would be my simplified expression. I can't simplify it any further. I can't combine any more like terms. I've gathered them all. And they are in descending order. Okay. Now, with this next one, B, I have brackets in there. But here's the thing. Because this has a plus sign, to remove these brackets, I just can make them go away. I would have an issue if that was a negative sign. If I was subtracting, I would have to distribute that negative sign. But because it's an addition sign, the brackets can just go away. So then it's just a matter of combining these like terms. So I have 7x squared and 2x squared. So I have 9x squared. I have 3x minus x. So I have 2x. And then I have negative 1. So that would be my simplified expression. Again, because this is a plus sign, it's easy to just remove those brackets. It's a little more complicated in the next example because I have a negative sign. So what happens when we have a negative sign is I have to distribute that negative sign. So that means that I'm going to have, the first one's going to be 2x squared minus 4x plus 5. That stays the same. And then I'm going to distribute that negative sign. So all I'm doing is multiplying everything in the brackets behind the negative sign by a negative 1. So this becomes negative 3x squared. Negative 1 times negative 5 becomes plus 5x. And then plus 2 times a negative 1 becomes negative 2. Now I can collect my like terms. So I have 2x squared minus 3x squared. So that would give me negative x squared. I have negative 4x plus 5x, so that would be plus x. And I have 5 minus 2, so that would be plus 3. Okay, so all I did is I went through and I gathered up the similar terms and then found out how many I have. Okay, and that would be my lowest terms. Now we leave it with that negative sign out front because I've asked you to express your answer in descending order. So that's how that's going to work. Now in the next one, I still have to distribute as well, but here I have a coefficient. So that means I'm going to be multiplying everything behind the brackets by negative 3. So this first bracket stays the same, x squared minus 2. Then I'm going to get negative 3 times 2x squared is negative 6x squared. Negative 3 times negative x. Well, a negative times a positive becomes, or times a negative, sorry, becomes a positive, so positive 3x. And then negative 3 times 1 is negative 3. Now I can combine my like terms. So x squared minus 6x squared, those are the same terms, like terms, so I get negative 5x squared. I've got my plus 3x, and then I have my minus 5, because negative 2 and minus 3. So it's just a matter of going through and collecting them. Okay, so hopefully that all made sense there. Now, this next one, you're going, well, I can't tell if it's a plus or minus between them. No, that's because these are multiplying, right? So we're going to remember FOIL or some method to multiply. If we use FOIL, it's first, outer, inner, last, right? So I would get x squared, x times x times 2 is 2x. Negative 2 times x is negative 2x, and then negative 2 times 2 is negative 4. If I combine those like terms, well, I have my x squared, but I have 2x minus 2x, so they disappear, right? This becomes 0, so x squared minus 4. Okay. Some of you might like to use kind of a chart method, so I have x minus 2 and x plus 2. X times x is x squared, negative 2x, 2x, and then negative 4. And these cancel out, so I'm left with x squared minus 4. Whichever method you use, I tend to use FOIL, but either method will work. Okay, and here we have another binomial pair that we need to multiply. So we have 3x plus 1 times x minus 6. If we're using FOIL, first, outer, inner, last. So using FOIL, I'm going to get 3x squared minus 18x, because 3x times negative 6 is minus 18, plus x, because 1 times x is 1x, and then minus 6. I combine my like terms, 3x squared minus 17x minus 6. Or if you want to use a grid to do your multiplying, 3x plus 1, x minus 6. So I get 3x squared, 1x, negative 18x, and negative 6. I add these together, so I get 3x squared minus 17x minus 6. Either way, get you the same answer. So whatever you're most comfortable with. I will never dictate that you have to do it one way or the other, as long as you get to that answer. Okay? So, we also need to remember factoring. Everybody loves factoring. So, it's a very important skill when working with polynomials. So first we ask, is there a common factor? Yes, then we have to factor out the GCF. So for example, if you had 3x plus 6, then you would factor out the 3 and you'd get 3 times x plus 2, right? Okay. Sometimes there isn't a common factor, so don't worry about that. Okay. If there's no common factor, or if there is, then you kind of look at how many terms there are. If there's 2 terms, you're going to check for a difference of squares. So difference of squares, remember, that's in the pattern x squared minus y squared. So that becomes x minus y times x plus y, right? That's difference of squares. But you also want to be very careful and check that possibly because there's sometimes if there's coefficients in there, it might be a difference of squares, but it's hard to see. Okay, so just be very careful. And then 3 terms. It says we don't deal with 3-term factoring until later in the unit. Well, I might do a little bit with you today. Okay, so we'll see. Okay. Because we're going to need that skill. And you should remember, but if it's 3 terms, then you want to check the form for trinomials, and then you can factor using any method. Sum and product, box method, decomposition, guess, and check. If it's a simple trinomial, meaning their a is equal to 1, they're pretty straightforward. If it's more complicated, where a is a coefficient, you might have to do a little more work. Okay, so let's do a little review. Factoring out the greatest common factor. So for A, factoring out the greatest common factor. So if I look at my 2 terms, 3x squared minus 6. So what I want to do is I want to take a moment and I want to say, is there a term that I can factor out of both of those? And 3 and 6 can both be divided by 3. 3 divided by 3 is 1. And negative 6 divided by 1 is, or divided by 3 is negative 2. Okay, pretty straightforward. And then I just want to take a check. X squared minus 2, it's a binomial. However, it is not a difference of squares. So I cannot factor that further. Okay, but it's always good to check, however. B, I have x cubed, 3x squared, and 4x. I have one common term to each of those, and that's an x, so I can factor out an x. So I get x squared plus 3x plus 4. Now, again, it said we're going to talk about trinomials later, but just to kind of review them for those of you who remember them. If I want to factor that trinomial, I can say, okay, what 2 numbers multiply to give me 4 and add up to 3? At this point, nothing, okay? Because 4 you can get by 2 times 2 or 4 times 1, but none of those add up to a positive 3. So that is actually done, okay? All right, looking at the next one. I have 4ax to the 6th minus 6a squared 4 or x to the 4 plus 2ax squared. So I'm going to look at each of those components. I have coefficients, I have a's, and I have x's. So what I want to do is I want to take out the greatest common factor of all of those. Well, I have a 4, a 6, and a 2. So the greatest common factor of those three is a 2. 2 goes into 4, 2 goes into 6, 2 goes into 2. I have an a squared, and an a. So the greatest common factor of those is just an a. Okay, you always look at the exponents. That's going to be your limiting factor. Then I have an x to the 6, x to the 4, and an x to the 2. So great, the limiting one is the lowest exponent, which is x to the 2. And that means I can divide each of those terms by 2ax squared. So 4ax to the 6 divided by 2ax squared, just think about that one. I have 2, because 4 divided by 2 is 2. A divided by a is 1, so I don't have to write anything down. And x to the 6 divided by x to the 2 is x to the 4. Okay? 6a squared x to the 4th. So negative 6 divided by 2 is going to be negative 3, right? A squared divided by a, well, that's going to leave me with an a. And x to the 4 divided by x squared is x2, okay? And then 2ax squared divided by 2ax squared, well, 2 divided by 2 is 1, a divided by a is 1, and x squared divided by x squared is 1. So I'm left with 1, okay? Alrighty. So that's greatest common factoring. Hopefully that's a nice refresher. And again, it's just taking those terms and figuring out what your GCF is. Next, we're going to refresh our memory on factoring difference of squares. Factor the following polynomial expressions if possible. So remember, difference of squares, oops, Mrs. Finley jumped a whole bunch of pages by accident. And that happens sometimes. Here we go. Okay. Factor the following polynomial expressions if possible. So, difference of squares, often we write it in the form a squared minus b squared, and then if we factor it, it's a minus b, a plus b. Difference means subtracting, and squares means that our terms are squares. So if we see where I have a perfect square subtracting another perfect square, that tells me I'm dealing with the difference of squares. So first one, x squared minus 9, and x squared is a perfect square, and 9, square root of 9 is 3, right? So that means that 9 is also perfect square. So this is going to be x minus 3, x plus 3. Now, we can also write this as x plus 3 times x minus 3. The order is not important. It does not matter what order you put them in, as long as one of them you're adding and one you're subtracting. Okay? Now, for b, when I look at them initially, I don't see perfect squares. 3x squared and 27, they're not perfect squared. However, what I do have is I have terms that I can factor out a GCF, and that should you always common factor first. So I look for a common factor. Both 3 and minus 27 are divisible by 3. So I divide the 3 out, get x squared minus 9. Negative 27 divided by 3 is minus 9. So now it looks very similar to my example in A in the brackets. So I would go 3x minus 3x plus 3. So when you first look at it, the first question should always be, can I common factor something out? And then look at what you have after you do that and see, can I factor it further? So looking at C, I have 16c cubed minus c. I can factor out something because I have a c in both of those. So I can factor out c first. And when I do that, I get 16c squared minus 1. Now 16c squared, Square root of 16c squared is 4c, and the square root of 1 is 1. So they're both perfect squares. So I'm going to get c, 4c minus 1, 4c plus 1. So you have to just basically look at those binomials and ask yourself, are they perfect squares? They may have a coefficient. That coefficient would have to be a perfect square as well. And they may not. Okay? All right. So, need to know a power. A power, these are some things that we've talked about today. So at the end of each lesson, there's this little need to know section. This can help you when you're filling in those pages at the beginning of the booklet. A power consists of a base and an exponent, can be multiplied by a number called a coefficient, can be multiplied with or divided by other powers, can be added to or subtracted from other powers. Exponent laws are rules that help us simplify or evaluate powers, and we kind of went through them, but this table will help us kind of understand them a little better. It's all there, right? It's a nice little tool to kind of refer to. So if you need to review your exponent laws, take a look. And what I'm going to say is that you'll notice that at the end of each section of notes, there's these nice little purple sections, or they might look blue depending on your screen. They're purple on mine. And they kind of summarize things. So these are good things when you're studying and when you're prepping to kind of take a look at. So we have the product rule, where it's a times, so if you're multiplying exponents with the same base, you add the exponents. We have the quotient rule where you're dividing exponents with the same base, so you subtract the exponents. We didn't really talk about it, but the zero power rule, if something is to the power of 0, it equals 1. Okay, so any power with an exponent of 0 equals to 1. So that's why if you get a over a, which is equal to a to the 0, that would reduce to 1. Okay, and then we talked about the negative exponent rule, where you can move it, you can write it as the reciprocal of the power with a positive exponent. We always prefer powers to be written with positive exponents. Sometimes when powers are added or subtracted together, a polynomial expression is created. A polynomial expression contains real number coefficients, whole number exponents, and can be written in the expanded form or factored form. To factor any polynomial expression, check for a common factor. If there are 2 terms, try to factor using difference of squares. If there's 3 terms, factor using sum and product, box method, or decomposition. And like I said, I think all your practice is going to just deal with exponent laws and simplifying polynomial expressions and then factoring, and it looks predominantly like you're dealing with difference of squares. So your assignment at this point is to do page 10, page 11. Oops, I'm on the eraser. Okay, all of it. Page 12 is where your answers are, so you can check them, but do them first yourselves and then use this key to check them. And then what you should do is go back and see if there's anything you can fill in the key terms page on page 5. Okay, and that's our first lesson for rational expressions.